Hello, Ching. Thank you very much for that introduction. And we're all here on screen, and we're very excited to start this session. As Ching said, my name is Sean Chiles. I'm a co-founder of the DigiFashion Group. I'd like to welcome you to this session, uncovering the truth about sustainability news in digital fashion and mass customization or production. And I have a little bit of a background that I'd like to just deliver before we get into the session. And that kind of sets the scene for the discussion and understanding more about our panelists today. Fashion retail as we know it today, fast, competitive, margin and discount driven, started to come into its own in the 1980s with the growth of fashion retail groups such as the Burton Group in the UK, where sales were driven by market penetration, range depth, stock availability and price. Since then, margin pressures and profit targets have continually led buyers and merchandisers to source cheaper production in offshore centres. Cheaper cost prices often go hand in hand with increased production quantities that often lead to overstock situations, which drive consumer discounts and overconsumption, impacting on sustainability and responsibility for companies involved. And of course, this damages our planet. If you juxtapose this with couture and bespoke made-to-measure fashion and dressmaking, where outfits are individually made for the customer and personalized according to their size and requests, it becomes clear that this overstocking can be minimized. Stock is then held only in fabric and trims and allows greater flexibility for future production. Sustainability and responsibility are major cornerstones of any fashion business today, where a key focus of addressing overstock and overconsumption can make a dramatic impact on this area. At the back end of design and development, digital tools now enable designers to create their collections completely in the digital sphere, only moving to fabric once the design, merchandising and buying teams are sure of the style they want to produce and having fine-tuned the lay for production to remove as much wastage of fabric as possible. These digital tools, when combined with others, are opening up the potential for mass customization and produce on-demand scenarios, which mirror the made-to-measure approach mentioned earlier. These new digital-driven approaches to reducing stock are leading to a new form of retail and a new form of consumption. And as Ching says, today we're joined by entrepreneurs Chang and Cyril Masia, the co-founders of 3D Fit AI and Liquid Fabric 3D. They focus on changing the way retail interacts with the customer in order to impact on sustainability, responsibility, and mass customization. They have developed a scalable solution called Retail 3.0 that resolves the challenges of garment fit and costs related to body scanning and custom single garment production in the retail clothing industry. Their solution uses proprietary 3D technology, free body scanners, and a micro-fashion supply chain to enable a paradigm shift from fast fashion to mass customization. By eliminating the need for inventory and offering individually designed and custom-made clothing at affordable prices, they provide a solution that benefits both consumers and retailers. Kurt and Cyril will share their decades-long experience in developing their solutions, and I'll ask Kurt to kick off the session with Cyril to outline their relationship, their development path, and the why of their product. So I'd like to hand over to you, Kurt and Cyril, to take us through your presentation today, and we'll follow with discussion and questions from the audience. And feel free to go into any direction you like, and I'll try to bring us into a good discussion about this area.
Thanks, Sean. I guess to start off, just a little background. I started as an industrial engineer in the clothing industry, and then moving from taking time motion studies on factory floors to eventually got into CAD/CAM, and then ran in charge of 54 workstation, Gerber station work CAD systems at Liz Claiborne. Eventually led to our obsession with the 3D technology into custom-made clothing. And thanks to opportunity to work with Cyril, we've been working on this for the past 10 plus years.
Okay, so quick presentation on my side. So I started in software development like 30 years ago. I'm trained as a mechanical engineer, and I worked for quite some years in CAD and finite element simulations and this kind of things, graphical product configurator, CAD interoperability, geometric algorithms, all these kind of things. And my position before joining Kurt into this challenge was head of platform engineering at a company where I kind of overlooked all the integration of the platform we were developing with external solutions and CAD systems. Okay, so that's would be my background. Okay, now I'm going to kind of switch to the slide that where we want to explain the missing links we identified in our journey. So before handing off to Kurt, I just want to mention at the beginning what we aimed at doing was to provide a cheap alternative to body scanners, and we wanted to extract measurements based on from two pictures of people. That was our first goal. Okay, and from that we ended up doing a lot more things, but that was kind of the starting point. So Kurt, if you want to look a bit about the gaps.
Initially we were just very, we just want to extract some measurements and give it to people to make custom clothing. This is back about 20 years ago, anyway, for me. Anyway, but then it was a whole new can of worms we opened up, because at first I was so excited. About 20 years ago, I started seeing body scanners at the SIGGRAPH show, and then they were scanning Arnold Schwarzenegger for the Batman movie. He was playing Iceman, and his whole bodysuit was made because of scanning. At the time, I was working with Liz Claiborne and said, wow, this is great. We don't have to send fit models to the Far East anymore. We can scan their body, have their body carved out, built as mannequins, so that the factory can use the same fit models for clothing. And then me, like probably everybody else who got so excited with 3D body scanning, is that we think that 3D body scanners is going to solve all the problems we ever had. Many of the problems I'm just going to quickly mention is that even as a big company, we couldn't get the sizing consistent from season to season. Okay, we were going to implement some kind of sloper, basic blocks programs, but it's very difficult to implement. And then we all assumed that with body scanners, the body data, we could give it to somehow magically that patterns can be made, and then patterns can be individualized to create a mass customization market. Anyway, long story short, little we know that, and we thought for sure there are tools on the marketplace. If we can't use CAD/CAM from Gerber, Electra, Optitex, whatever, we could probably find it from 3D packages from SolidWorks, Rhinos, or 3D Studio Max, or Maya, or some kind of compensation between the CAD packages, and then come up with some kind of magic formula to create custom-made clothing. But little we know, that wasn't the case. And then we get now a big mixed soup of 3D CAD packages available now. And then one of the things that we want to help the audience to see, that people say they can solve issues, but then we as audience or consumers of technology thinking that, wow, they're going to solve everything for us. But no, they don't. What they actually solve is one of the things that we want to help people identify is that the CAD systems out there today, like Claw 3D, Browseware, TugaCAD, or anyway, Style 3D, blah, 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 blah. They are designed to do specific things, and we have to separate what they do. In other words, some categories, and Cyril, feel free to jump in when you feel that what I'm saying, it probably needs in additional details. So right now, the products on the marketplace, you can probably define them and categorize them into different categories. There are systems that designed for 3D body scanning. Okay, there are systems designed to measure for measurement extraction. There are systems designed for garment simulation, and there are systems designed for virtual try-on and size predictions to reduce online returns. And of course, then there are software designed for gamer developers to do for entertainment purpose. And each system is designed for specific use. And then what we did is we designed our system specifically for mass customization.
Yeah, so thank you for the introduction. Good. So as you mentioned, so there are a number of challenges for doing like mass customization. So so I just want to make something clear. What we to understand as mass customization is the ability to create garments that fit the final customer in our case. Okay, so that's a very ambitious goal. The idea is we currently already have the solution, and it's something that is done where you can like custom print garments in standard sizes. Okay, you see that for t-shirts, for kind of like in general like loose garments. We kind of wanted to do something to actually make garments that fit people. Okay, and that's why we started looking at the 3D body scanners. And then the question we were confronted with is, how do we go from the 3D body data, from the measurements, how do we go from that to patterns that are ready for manufacturing? And ideally, you kind of need a different pattern for each customer because of the challenges posed by standard sizing that actually only fits a small percentage of the population. You really need one pattern for each customer, and the CAD systems around there are provide a wide range of functionality, but it's a lot of click, and it requires a lot of time, to prepare or adjust a pattern. Okay, so and if you really want to go into volumes, it is, I mean, you cannot rely on operators like doing click here all day long in CAD systems. Okay, so you can do that for prototyping, for design, for exploring options. But if you really want to like mass produce custom, made to measure, let's say, garments, it does not scale. Okay, so that was the another problem we identified.
Yeah, okay. And then just want to jump in is that a lot of the CAD system, pattern design CAD system now have this module called made to measure. Okay, this made to measure module does work. However, it was solely designed for suits and shirts for men. And some of the algorithm, the setup is that you could set up a relationship between line A and line B. When line A changes, line B needs to do this. But this requires quite a bit of sophistication, but it's very unflexible. And then when it comes to women's clothing, this made to measure module just doesn't work. And this is where we had to create our own algorithms to basically build the whole CAD system. And then the funny thing about Cyril is he's an engineer. And when we started this, he actually taught himself pattern making. Okay, this is such an incredible story that for the like 2 or 3 years. And then based on our investigation into pattern making, we actually had to go back into history, why pattern makers do certain things. As it turned out, some are just because that particular pattern maker decided that this will look better than some other, so they created these rules and whatever, had no real reason to it. Anyway, that's the jumping. So the made to measure, everyone had heard the made to measure module, but yes, the question is there anybody on the marketplace selling women's custom made clothing? And you have a hard time finding it.
Yeah, that's another. So it's good you mentioned the rules in pattern making. So one thing that struck me when I started like looking into pattern making was that you have a number of things that look like food recipes. So basically, you do this, you do that, and then you add 1 inch. So why 1 inch?
Yes.
I mean, why 2 inches? This and these are kind of like in the fixed values, okay? Or maybe you can have a range, but how do you adapt that to different body shapes? Like you mentioned Arnold Schwarzenegger, or a petite person. How do you? I mean, 2 inches cannot be something valid for everybody, shape and size. Okay, so there is more behind pattern making than just adjusting things. So these are kind of all the, I mean, some of the gaps that we identified. Okay, and some other you have some other barriers for adoption. It's the price, for example, of 3D body scanners. I mean, especially a few years ago. I mean, those end up like being very expensive tape measures. Okay, so that's also a barrier of entry, the price. So that's what we started looking at easy and cheap data acquisition. Okay,
Right.
unique data acquisition. Go ahead.
Cyberware started off just talking about price. Back in 1990s, the first cyberware body scanner was a laser base, 4 columns, 4 cameras, 4 heads. It's $250,000. Okay, now I guess people have comes down to like maybe you can get one for $20,000, $30,000. And believe me, I had when I started with I was obsessed with the body scanners. So I went to London to see this, in the US see this, and then not all body scanners are equal. Okay, a lot of them, I guess the very beginning, because the cyberware scanner was designed to do the Caesar project. I don't know if people know about it, but anyway, it's scanning 2,000 civilians in the US and 2,000 civilians in European countries. And then they were sponsored by the automotive engineers and the US Air Force because they want to design cars and they want to design fighter jet helmets. So they needed accurate data. But that data was helped by anthropologists who actually, with that project, they actually place landmarks on the bodies with the Caesar body scanning project, so that you can go back and measure based on these landmarks. Now, that's the only data set out there that I know of that exists today. This is almost 20 odd years ago. None of the new scanners, when they tell you the body measurements, it's their algorithm figuring it out. It's not some anthropologist placing these landmarks on the body itself. The Caesar project, they actually have little boxes they place on the body. So when you take a close look at the Caesar project, all the bodies have little boxes, but these boxes are landmarks of exact measurements. So that's what I want to point out, is that body scanners, the body measurements they give you, hey, good luck. Different people, different body scans. Maybe if they did a survey or test, the same person being scanned by 5 different body scanners, you may come up with different variations.
Okay, so as you can see, there are a lot of gaps. I mean, and we some of them we have them identified in the beginning. Some of them we found out in our journey. Okay, and I'm going to switch to the next slide.
Okay, one thing I want to say that unfortunately we thought at the beginning that body scanning companies would share the data with us because we want to use 3D bodies, but when we did ask, no, because they want to make money from the body scan data, so that the only thing they're going to give you is measurements. Caesar project is the only one that actually offers a full body set of data. So we couldn't work with the measurements alone because we're working with 3D bodies. Anyway, that's just one thing I want to throw in, that don't think that they're going to offer you the 3D bodies to work on.
Mm-hmm. Okay, so basically, our work in to solve or to fill in these gaps can be summarized in this slide. Basically, we kind of try to add the missing links. Okay, so one big part of this work is automating the pattern making. Okay, so as I was saying, you have measurements. You have a 3D of the person. You have a number of measurements, and then that's how you go from that to a pattern that you can actually use to manufacture one of a kind. I mean, in the sense of custom-sized garments. Okay, so that's one important chunk of our work, and we ended up, as Kurt said, we ended up creating our own CAD system. We have all the geometric operators we need to generate patterns and also to operate on 3D geometry. The other thing is that it's not a CAD system that is intended for an end user to click here and there. So we're not doing another user interface. Yeah, exactly. I mean, that already exists. Our purpose is really to be able to automate. I mean, you have to automate the generation of the patterns, or otherwise, I mean, you can do customization, but you won't get to the mass customization. If you want to get volume, it has to be automatic. So that's why we have this, like, and you can see that as black box that has all the geometry operations needed to generate a pattern. And basically what we have in is the 3D of a body, and we get patterns for the different styles as an output. And then within that, we added what we call like artistic intelligence. So inside our system, you can define, Kurt was talking about made to measure and the limited operators they had. Here, we can define the logic that it can be pretty complex as to how the overall pattern or some details of your pattern will adapt to different body sizes and proportions. Okay, so it can be applied to a lot of things, but we will see afterwards a few garments that we make. You can think very quickly about like the placement of a pocket when you're making a pair of jeans. I mean, how does that placement and the sizing of the pocket, how does it change with the different shape of the bodies? Okay, how do you place it? Do you want to place it like parallel to the yoke, or at an angle to the yoke, or or do you want to place it like horizontal? So we kind of with our system, we are able to specify how that placement changes with like different body shapes. We'll take into account the geometry of the body. Okay, that's just an example. Okay, and we call that artistic intelligence. And with our system, part of the design activity is actually defining the rules of how the garment evolves or morphs with different body shapes. So that's what we call artistic intelligence.
Right. And I want to throw in is that traditionally, I don't know if the fashion industry insiders know that, but the outsiders doesn't realize this, is that when a designer designs a style, they design a style for a fit model. And this fit model generally is the medium size, if we call it that. And then, of course, once they design this, most people don't realize this, that's it. They're not worried about how it looks on a 3-4 sizes bigger than the fit model, or 3 or 4 sizes, 5 sizes smaller than the fit model. And that responsibility is delegated to the grader, okay, or whatever in the factory. And then the merchandiser or the production people give specifications for 5 sizes bigger should be this measurement. That's a flat measurement. So what I'm trying to say is, in other words, that the design spirit that was intended for that medium size, unfortunately, a lot of times gets lost when you go 2 or 3 sizes up or 2 or 3 sizes down. So that the aesthetics of the design is lost. A lot of times consumers try it on a garment and say, hey, in that showroom window, it looked great. I love that styling, but somehow it doesn't look like that on me. Is it because of me? No, it's not because of you. It's because somehow the grader, the pattern maker generally is held given that responsibility, doesn't have the same design aesthetics as the designer when they grade the garment up and when they grade the garment down. So that's why we have to build in this artistic intelligence. We call it AI. And then on top of that is that a lot of times designers don't know what looks good. They would give you an answer, I just know what it looks good. And then I can't tell you why, but that's my black magic, okay? But when you break it down, when you really break it down, what comes down to is proportion. Leonardo da Vinci drew that big circle with the man with the spread of the arm, and basically he's telling his students, when you do something, a sculpture or painting, as long as you follow that particular scale, then it's going to look good. Okay, so we took that and we say, hey, we need to build proportion design into the art. We call it artistic intelligence, and that's why we're able to bring that design spirit for everybody.
Yeah, I'm gonna maybe speed up a bit. Yeah, so that's those are like two big things, two big parts. And then the next questions we're confronted to is, okay, now that we are making garments that are basically made to measure, represents a big change in terms of manufacturing. Okay, because it's not like we have or we are going to do like 500 pairs of jeans of a given size, and then we can you have like multi-layer cutters and cut 50 or 100 layers at a time of all pieces that have the same time. Here we really have, I mean, we don't have like two patterns. I mean, for two people, we don't have two patterns that are the same. Okay, so that changes also the approach regarding manufacturing. Okay, so we're switching from like really a mass manufacturing, where you have orders that are placed for like hundreds or thousands of pieces, and to something that is like one of each. Okay, and so we developed also this micro fashion supply chain, where we would try to promote local manufacturing and local industry and local craftsmanship. Okay, so
for the mom and pop shops, for individuals, designers, we want to create. One of the things that is fast fashion is big factories, but why not bring it back to the community? And then why not share the profit with everybody involved? So that's one of the things that we would like to accomplish. And one of the things about artistic intelligence, that this is one thing designers can really have a lot of fun playing with, because we're using optical illusion. So we can actually, it's almost like plastic surgery without the plastic surgery, using lines and curves, color and shapes, different combinations.
Yeah, okay, so there are kind of a lot of, so Kurt mentioned the sharing the profits. There are a lot of advantages of having like a more local supply chain and manufacturing chain. One is you save costs in shipping, okay? And maybe the only thing you can ship, or maybe you can source closer, is the raw material, the fabric. But then if you make and you manufacture locally, you have like huge savings in shipping. Okay, because I mean, if you have big factories in Vietnam or in India or in China, then you have to ship that with containers throughout the world. Okay, so that's I mean, there are multiple goals that we can attain with that. And it can also make sense because we're doing like one of a kind for each of the garments. Okay.
Right. Also, we are also having centralized. We can leverage bulk buying because you talk to mills, they want 300-yard minimum. Now, a designer can't buy 300 yards of the minimum, and then so we could buy 3,000 yards and share amongst 3,000 designers. And at the same time, we could share other resources. For example, digital printing. It's quite expensive, but given pigment digital printing these days, you can basically print anything like your desktop printer. So that's expensive. But if we have a central technology center at each local community, then everybody is sharing that digital printer.
Okay, so I'm going to switch to the next slides, I guess, where we talk a bit more about this these aspects. Okay, so around like 3D-Fit.ai, we have developed this micro fashion supply chain. We'll see the advantages has. The mass customization, we had a word about that, Industrial Revolution 4.0 and Retailing 3.0. And so, I mean, most of these are kind of enabled by the possibility of generating patterns and printing them, as Kurt just mentioned. Okay, so
there's a lot of buzzing buzzwords in the marketplace, but pretty much they're talking about the same thing, right?
Yeah. So as I mentioned, when we started at the beginning, our first goal was to have a cheap data entry. So being able to build a 3D of the body from 2 photos and take measurements from there. And basically with that, you have a low barrier of entry. We have an app that runs on a tablet where you can like take pictures in the shop, and basically you take pictures of your customers, and we will make garments. So once we extract the body, we call it a 3D body double of the customer, then you can order any garments we have in catalog, and we'll generate a pattern for that person on demand. So it's basically when you sell one, you make one. So you don't have stockpiles of garments. So that means like no inventory, no returns, and all this translates in saving costs and how you manage it. Okay.
Right. I also want to point out that most people can't make the decision based on a virtual garment that's shown somewhere. So, but we found that when someone can actually see an actual garment, then they can touch and feel, and then, because it has to do with perspective. So if you're at a location, you see one garment, one particular color, and then you could let yourself loose, because then we could show them virtually 10,000 different other colors that they are more willing to make that jump in to make purchase. Whereas when you see something on a virtual online, people are reluctant to make that decision.
So the retailing 3.2.0 for us is basically you have shops that have, instead of having a large stock, a large inventory, they have samples, and people can look at the samples. They kind of try them on because it's not their size, but we can make one for their size, and we can show them how it would look on them. So that is possible with like a cheap data entry. The non-inventory, I mean, it is important. Inventory is a huge cost in the overall industry. You're aware of that. And there is some information available, for example, from H&M, which in 2018 reported that they had like $4.3 billion in unsold inventory in the year before. And $4.3 billion. It's a lot. It's not only a lot of money, of course, but it's a lot of raw material that, I mean, a lot of garments you actually made for nothing. Okay. So having no inventory is a big thing.
And Retail 3.0 also opened up opportunities for non-traditional retail shops. In other words, hair salons. You know, why not have a rack of assortment of different colorful jeans that the hairstylists can recommend to their clients, and then art galleries. You can't afford that particular painting, because there's only one of a kind, but how about the artist designing the painting onto the jeans or pants or dresses? So this retail 3.0 is just not simply as the traditional point of sale.
Okay, you can think of jeans also. Okay, so next thing is industrial revolution 4.0. So as I mentioned, so that's mostly about using like the new technologies, or most of what we developed is software actually, and processes. All that software runs on a private cloud. We have a number of also modules that interact with manufacturing, interact with final customers. So we have this data taking app, for example, that allows to take pictures. We are using artificial intelligence for a number of internal processes. We are looking into additive manufacturing for we're thinking about like possible usages of additive manufacturing, like basically like 3D printing we're looking into materials. That could be interesting, for example, to add innovative accessories, or for example, we're thinking about the motorcycle suits that usually it's kind of garments that has to be relatively close to the body, and you really want the protection, the protective additions to be located at the right places and the right sizing. Okay, so those are things we're looking into also. So
one of the reasons we're combining all the technology where we're controlling is that from our past experience, we've learned that when you can't control all your core components of core technology, when generally competitors bite each other out, they throw in the monkey wrench. From my personal experiences, for example, at Liz Claiborne, we used microdynamic systems, CAD systems, but Gerber realized that they want the market share. So they actually purchased microdynamics. And when they purchased microdynamics, the microdynamics users were forced through a evolution to adapt to a new system. And we've seen a lot of times by designers who hire people write their own source codes to do custom clothing. But when someone hears about that particular something is successful, they buy them out, and then the designer is sort of left with nothing. Then they have to start from scratch. So that's one of the things we have created a system that's fully operational on our own, standalone.
Yeah, kind of try to reduce, at least for the core components, to reduce dependence, depending on third parties. Okay. So mass customization, we already talked about that a bit. So mass customization in our mind is clothing that fits. It's making the clothing fit, not only the look and the print, okay, which is already possible, but really make one of a kind for each customer, a specific garment that enhances like customer retention. As we said, we have like zero inventory. We see that as an alternative to fast fashion, because what we trying to do is like high quality garments that last, okay, are good looking and last, and that you can wear in lots of occasions. Okay.
I'll just add to that is that, for example, we're making jeans it doesn't look like jeans. It feels like jeans. It's made from jean fabric. It's comfortable as jeans, but because of pigment digital printing on cotton technology today, we can print it, make it look like a pinstripe suit jeans. So we call it 3-in-1 jeans. In other words, you can wear it to the office. Next, in the afternoon, you could wear it to rock climbing, and evening time, you can wear it for evening dinner party. And then This way, it's less of a garment, but it's like we say, less is more. In other words, the no more wasting. Buying what fast fashion trying to do is they're brainwashing consumers to make consumers start to feel that clothing is dispensable. It's like from season to season, you need to buy new clothing because it's so cheap. But at the same time, you can imagine the waste is created. One of the reasons they do this is because they can't predict what people want. So one of the things you do is you play the odds game. Okay, I have 10 styles. Last year it didn't sell. Only 20% sold. So guess what? This time I'm going to make 20 different styles, and 20% means 4 styles will be sold. So that's somehow it's getting worse and worse. And some online companies, they actually made it so cheap that anyway, I don't want to mention any names, but we want to reverse that. Quality garment that you wear season to season for 10 years. That never goes out of style.
Yeah. So I'm going to push it a bit. So, and the supply chain, we already mentioned quickly this. So basically, we want fair and ethical fashion where we work with local craftsmanships, high quality materials, and we want to have a 100% transparent pricing structure, like everybody in the supply chain kind of benefits from this approach. Okay.
And consumers will know who the designer is, who the sewer is, who the product development is, so that everybody knows how much they should get from that garment. In other words, we get our little bit of technology commission, I guess you call it.
So we're almost out of time if you want to leave a few minutes for questions. So I'm gonna run through the next slides. So this is a summary of a black box. We take pictures, we get the outlines of the body from the pictures. That's basically what we need. We don't need the picture anymore after that. With those outlines, we're able to do the 3D body. And then in like a fraction of a second, we're able to generate patterns. Okay. The outline extraction is a one-time process unless you gain a lot of weight or use a lot of weight. Okay, but as long as your body shape stays the same, with that input, with those outlines, we're basically able to generate patterns very quickly for the different styles that are in the system. Okay, and then we'll show a few examples of those jeans that we were talking about. So we have jeans right now. We started with jeans because it's one of the most difficult garments to make, to measure. Okay. And here are like different examples of jeans we made, like for example, different body shapes. Okay.
Right. And I want to point out here is that it's a scalability issue. In other words, a good master pattern maker probably can make a pair of well-fitted jeans in about 2 days on trial and error, this and that. And then that's not scalable. And then if you have 10 customers, take 2 days, hey, that's 20 days. Now, with us, if you had 10 customers, it takes a few seconds. So that's the key. That's what we developed our software, so it's scalable.
Okay, so you can see examples of the jeans. We can see examples of so for a few people, we asked them to, wear our jeans and wear the jeans they're used to wear. Okay. So
you can see the optical illusion what we create at the bell bottoms. Actually, Cyril, I said it's interesting for me because I'm not a programmer, but he explained to me that the French curve that we use in pattern making in the clothing industry actually it's not enough. Okay, the French curve it's a beautiful curve. The exit ramps off freeways are French curves. Okay, and then the rulers that we use in pattern making in the clothing industry, you have the long hip curve or the different type of curve, but they're all French curves. For the bell bottoms, we couldn't use French curves because it just doesn't work to give you that optical illusion. So Cyril actually has created the new curve for the garment industry in our own CAD system.
Yeah, so it's so that's very flattering, but we're using like pre-existing curves. It's just that we're using the degrees of freedom they offer in like different ways. Okay, and we also adapt the location. I mean, where the bell bottoms, you can see on the right in the picture, where the bell bottom starts opening. That location kind of depends on each body and the proportion of the legs of each person. Okay, and the size also of the opening at the bottom is also some proportional to the body. Okay, so these artistic intelligence were built in for pockets, for the bell bottoms, for a number of things. So that's part of the definition of the style. Okay. Yes, here you can see other examples. So that's same young lady. Okay, with our jeans. Okay, so this is a more high-waisted one. Okay, bell bottoms again. And more examples for men. Okay, so men, the style for men is a bit more squarish in general. Okay, but we think it looks good, and if you see it really fits and grabs the body pretty well.
And it's extremely comfortable. And you can see from this picture, this is what I'm talking about, plastic surgery. In other words, when you wear our jeans, you look 10 years younger, okay? That's, you can see it, especially from the one on the right side, right? That's actually Jamie and his favorite jeans, that's what he wore. And then when he wore our jeans, hey, he looks 10 years younger.
Okay, and last slide for question is about the supply chain. I mean, we already mentioned that a number of times during the talk, but basically, so the customer goes to one of those like Retail 3.0 shops that can be, you know, regular clothing shops, can be gyms, can be hairdressers, as got mentioned. From there, you place an order. It goes to that technical center, service central, where we can, if artisans don't have the hardware, we can print, do the cutting. It can go then to artisans for sewing, and then our technology is in the middle to coordinate all this. Okay, so
and then the Retail 3.0 also offers a transition for existing retailers, because right now you have a whole huge inventory, and because the way we have designed a simple iPad, or simple pad, that you could have a section for customized clothing coexist with your inventory, and then eventually you can transition you from using the large floor space into less of a floor space, and that's an evolution, not a revolution. So the retailers don't have to panic. That's one of our intentions.
okay, so I guess that's all for the presentation. I mean, we could talk about that a lot more, but we are running out of time, and I want to leave a few minutes for questions.
Thank you, Cyril, and thank you, Kurt. That's really fascinating, I think, to see your journey and to understand how you've started off, as engineers, if you like, and coming from a data background, a purely data background, and now you are at the intersection of data and design and retail, and you're part of pushing the new retail approach, which really is centered a lot on produce on demand, I think, as you're touching on here, which is the area we all in the industry, we are all focusing on, and we need to enable that to happen. And I believe that what you're showing us here is a process and technology that is going to begin to address that and to help to address that. I do have a couple of questions that maybe we can just discuss. I think we just have a few minutes left, so we just discuss on our own. And one is, you touched on this, and I really like your artistic intelligence, sorry, as an alternative to artificial intelligence. This is really nice. I'm a designer, I come from that background, and it's great to hear that. And this is the interesting part, where you're taking data and you're taking technology and you're taking an original design, for example, which, as you say, may have been created on a medium-sized body fit to a standard fit, but you're then changing that and grading it to personalized sizes, and maintaining the design integrity. But how do you maintain that design integrity within your system? And I assume this is the artistic intelligence element, where you know, the angle of the pocket changes, the size of the pocket changes on the back of a jean, if we focus on jeans. How do you do that? Is this just the way you've built your software? What have you built in to do that? Who would like to answer that? You don't have to give the secrets away, but it's just interesting.
I'll leave it to Cyril, because, you know,
yes,
I don't know what the key parts of it, right?
So the key parts of it is, so basically our system is what back in the past we could be called expert systems. Okay, so it's mainly like rule based, but we can make rules like pretty complex. And actually the defining the behavior of the different elements of your pattern depending on the body shape is part of the design. So in our case, it's not only you have to design the medium size. Actually, you're designing for us is like really creating those rules. Okay, and then we have a set of like 10, goes like kind of baseline, if you want, of 10 different 3D body doubles of very different body shapes and body sizes. And we can generate, since we can generate those patterns like pretty quickly, we have those into our system, and you can see the patterns in a matter of seconds. You can see all those other patterns. So each time you do a change in the rule set, you can see how those patterns evolve. So you kind of need to know how to read a pattern. And then if you're satisfied with the sizes, since as I mentioned earlier, we just have the outlines of the customers, we start to have a big base of outlines that we can derive the 3D and then derive the patterns. So we can generate those patterns, all those patterns can pretty quickly. You can then visually inspect them. And we're working into solution to integrate that, to automate that to some like with visualization and simulation. We can have you can see those simulated like for different body shapes. Okay, so it's not so. I guess we kind of reverse the process. So instead of designing in 3D or with like a 3D or a CAD system and designing like one size, here you really think into in terms of the rules you want your design to obey to how you want design to morph, and then we can generate a lot of patterns. We're working on automating the simulation, so you can look at different body doubles and how it looks, how it drapes, how the things are in simulation. Okay, so simulation is just kind of a validation, pretty much like in engineering. When you're doing an airplane, I mean, you do a lot of simulations. So here it's what we do. So the design for us is kind of different thing. Okay, it's really creating those rules.
Yeah, it's very interesting. I think it's very, very interesting to understand how you're doing that and how that fits into the skill development of the designer today as well, where they're also now using Clothes 3D or Style 3D or Browseware, for example, to design their garments, and also designing for diversity on different body shapes and different sizes. So designers today, young designers, are doing that. So they are creating customized avatars. Yeah. So
you can still use those tools. Okay, they're great for that. Okay, but then the next step is you have to think about how you design morphs, how it has to change, how the pocket sizes or whatever placement of the bell bottom, how that changed with the body shape, and for that the designer is also would think, well placed. I mean, should be well placed to say, okay, I want you to look like this and look like that. Okay.
Yeah, these elements that you're talking about are actually, in my experience, especially when you work at a bespoke level or a couture level, they are exactly the design fit sessions that you make on the body at different sizes in order to satisfy the customer, so that somebody who is a very large size or a very small size is getting the look and the feel of the design, the original design that was created by the designer. And when the designer sketches, they generally sketch to a fairly standard body shape, whatever it is, men or women. So, but then the reality is you are producing for a customer who isn't that size and isn't that shape, and therefore you need to adjust. And it's always been about the fit session, and then the cutting, and the cutter would also, as you've said before, give their own interpretation to certain things. But this is a really it's a really great new development, I think, where you're bringing all these things into play in an automated system. And I know we are pushed a little bit for time, but one last thing was about the microfactory side, and the fact that, if we're going to do produce on demand, it means that the customer has to wait. They can't have something immediately. It is not immediate. Now, this is a big kind of stone that we have to get over in retail, because customers today, particularly with fast fashion, are so used to buying that, picking everything up, putting it in a basket, going to the checkout and taking it home and wearing it once or twice or whatever, or returning, whatever they do. But they have it immediately. And this has become a kind of inbuilt expectation. Whereas in the past, with dressmaking, with bespoke, with couture, you had to wait. You tried a sample on, you saw it, you understood how it fit on you, but you had to wait for it. So we're kind of going back a little bit to that area, which is the only way we can really do produce on demand. But how do you think we're going to get over this? What's going to happen from the consumer's perspective?
Well,
Any insight?
Okay.
Yeah.
It's it's the old saying goes that good things are worth waiting for, and in the way you say instant satisfaction, gratification is one thing, but I've learned I like old cars. Okay, I bring these old cars to I guess they rebuilt them, and then you think that the wait time is actually suffering or waiting for it. Actually, it's enjoyment. You're anticipating something, so that in a sense, yes, but at the same time, the waiting period, it's an anticipation. And a lot of our people that have been customers and people that have been working with us as testers, they really get very excited. So that whole week or 10 days that they wait for the jeans, they're excited. So that's another way of looking at it: glass half full, half empty. So it's actually an enjoyment if you can look at it that way.
Yeah, I think that's great. I think it's great to see that it's also it's building something new into retail as well, and that retail 3.0, which is great. There's excitement and anticipation. So there's a whole load of marketing things that have to go around that would be really interesting to see. But for this session, I think I'll wrap up now and thank you both, Kurt. Thank you, Cyril, for this insight into your business. I'm moderating the next session, so the next is delayed a little bit unless I go on too long. But thank you very much, and good luck with your developments. And we hope to hear more about you and more of you in the future.
Thanks for the opportunity.
Thank you for the opportunity. Thank you.